We are group 9 from cohort 6, and this is our 2D project. The project overview is that we realize that food is a necessity for everybody and that food security is important. So we realize that wheat is the most grown crops all over the world, and it's the most important form of food that people consume. So food security for wheat specifically is very important. So that comes to our problem statement. So we want to see how we can predict the factors that have the most effect on wheat production in that country. These functions to prepare the data to our data set for us to further model our linear regression. So this one is to split the data, this one is to prepare target, this one is to predict, and this is the function to find the mean square error, which we are going to dive in later. And then so for our data set, we began our research and we came up with factors that we thought would have an influence on wheat production. So so this includes both environmental and economic factors. So you can see here the response variable has to be the production of wheat because that's our Y, and then the independent variable includes factors like rainfall, rural population, pesticide, area harvested, wind speed, and innovation index. But please keep in mind that not all of these are going to be have a linear relationship, but we thought that they would have in the beginning. And then we import the data for all of these factors and the wheat production into our CSV, and then we combine them into these columns and table over here. So we also realize that some of the data, they have blank values. So what do we do with that is that we improve it by replacing the non-data with mean values, or we even research some more online externally. So and now we plot them using the plot function to plot out the factors against the Y. So each of them show you can see how linear they are from the graph, from looking at the graph, and we realize that some of these are more linear than others. So we know that which factor has more likely to have a linear effect on the wheat production.
Alright, so before we can construct our model, we need to have some iterations and prepare our features and target. And that's why we use the box plots to see the outliers. And as you can see, there are some outliers for the rain, for the pesticide use for the rural population, and area harvested. And we started building our model, linear regression, and then we say all the values of our features that's more than the upper bound. We just exclude them, and therefore we exclude the whole row. And at the end we had 127 countries, but at the end we only left with the 181 country. And then as you can see, while doing the plots, our data became more linear in a sense, because we removed the outliers that would have a negative impact on our linearity.
So to begin to validate the model, we first need to find the linear regression between from our model. So to do that, first we use this Python code to prepare the data here, and we split it using the functions that we have already put it as explained by my teammates. And here we initialize the data using these values. And then after getting all these values, we use this function to calculate the mean square error and finding the mean square error. And this is our values right now. And as you can see, the values for the mean square error is very not appropriate. It's very high. So to improve our model, we use the same function, but from the data itself, we standardize every data that we split here. We standardize everything, and then we got this value for our mean square error and root mean square error. We also tried another way using normalization. Basically the same function again, but using the normalized function. And these are the values right here. And from there, we can say that from the values itself, the normalization gives off a lower value of mean square error, which means it has less errors, and which means that our model is better if we try to normalize it.
So as my friend Renan has said, normalization has better accuracy than standardization, and from our model we can identify which factors will play a part in influencing wheat production. We also must consider that there are other factors that like social factor and political factors like war and tension and all that, which will influence wheat production. But then these kind of factors are very hard to compute into data or like numbers. So we need to consider it when we are using our model to predict the factor that will influence wheat production. Yeah.